All right, so today we are skipping two sections, 8.3 and 8.4, and going to section 8.5. This is the last topic that you would need to know on sequences um, in reference to the CASP. Okay, the other stuff that you have to know in sequences doesn't have to doesn't apply to the CASP. So just the last three, or these three sections, 8.1, 8.2, and 8.5, is what's required for you guys to know for CASP exams, the state exams. So the first part right here that I put is, what is a geometric sequence? So we learned last time that an arithmetic sequence was a sequence of numbers that had a common difference, right? In other words, between each number, they either added or subtracted the same amount to get from one number to the next. The geometric sequence is almost the same thing, just that instead of a common difference, we have a common ratio. So it says a sequence of numbers that have a common ratio or the same number multiplied between the numbers. That's what a geometric sequence is. Okay, so it's a sequence of numbers that have a common ratio between the numbers. So the same number gets multiplied throughout. Okay, now what I wrote under that is what we're going to have as our explicit formula. Okay, a sub n equal to a sub 1 times r to the n minus 1. It's not today, or it is? No. Okay. It's next month. Okay. So a sub n is equal to a sub 1 times r to the n minus 1, or a sub n equals to a sub 1. Now this is the same thing. Notice the only difference is this one has a parenthesis around the r. This one just has a multiplication symbol. But I want you to see both ways, because sometimes in some people will write it with a times notation, the little dot. Sometimes people will write it with a parenthesis instead. Okay, so it just kind of depends on how they write it. So just know it occurs both ways. Okay, notice we do have an a sub 1 in the front of the r values, right? So there's an a sub 1 there. R is our common ratio. So that's the number that's getting multiplied. So yesterday, some people were doing the homework and they're like, what I noticed, like in this sequence, it's not that they're adding or subtracting, but if I multiply by 2, by 2, by 2, I get these numbers. And I said, well, yeah, but that's not an arithmetic sequence. I told them that's a geometric one. We're going to talk about that today. Okay, so how do you find a common ratio? Okay, because sometimes they're going to tell you to find it. They're going to give you the numbers. You're going to have to find it. So here's how you do it. Given a couple of terms, so say you're given a couple of terms. The way you find the common ratio is you got to make sure that all of these terms, when you divide one with the other, give you the same value. Now you're going to divide them like this. The bigger term divided by the smaller term. Okay, so a sub 3 over a sub 2, a sub 4 over a sub 3, etc. Okay, so you don't do a1 divided by a2. Don't go left to right. You're kind of going right over left, right over left, right over left. So a2 over a1, a3 over a2, a4 over a3. And if you keep doing that and you get the same exact value every single time, then that's equal to our common ratio. That's equal to r. Okay, so you're basically going to be dividing two numbers. Okay, kind of like that. You're dividing those two. Always the bigger term divided by the smaller term. Okay, and I don't mean bigger in value or smaller in value. I mean like a sub 4 is bigger than a sub 3 in terms of the term numbers, right? 4 is bigger than 3. 3 is bigger than 2. So always do the bigger term divided by the smaller term. All right. So again, a geometric sequence is a sequence of numbers that have a common ratio. A common ratio means you multiply by the same number over and over again. So we're multiplying. The way you find that common ratio is through division. Okay, dividing the next term by the previous term. Okay, so this first part, pretty easy, says, are these geometric sequences? Sorry. So if they're going to be geometric sequences, they need to have a common ratio. So what I'm going to do is I'm going to divide. Okay, I'm going to do a lot of division. So example 1, are these geometric sequences? The first one is 3, 5, 9, and 17. So I'm going to divide like this, okay? Let me change the ink color here. So 5 over 3. Well, I can't really simplify that. The next one would be 9 over 5. I can't simplify that. And 17 over 9. Do these match in value? Like 5/3 is not 9/5, and that's not 7/19. So this is not a geometric sequence. Okay? They're not the same. They need to be the same. After you simplify them, even if they're fractions, they need to come out looking the same. So let's try doing the next one here. So I have 2, -8, 32, -128. So I'm going to divide like this, okay? So -8 divided by 2, well, that's -4. 32 divided by -8 is -4. Okay? -128 divided by 32 is also -4. So do I have a common ratio? Yes. Yeah, it's always -4. R is -4. So this is a yes. R is -4. So notice it's not hard to identify a geometric sequence. You're just going to divide the terms and see if they all come out to the same thing. If they don't, then it's not a geometric sequence. If they all do, after you simplify them, then it is a geometric sequence. Okay? So these problems, pretty simple. Just do a little bit of division. Maybe you're going to need, I'll bring out the calculators after. But maybe you might need a calculator for some bigger numbers and stuff like that. But just divide, see what happens. Okay? All right. There's 4 examples, by the way. So example number 2. Given the first term and the common ratio, find the first 4 terms. So they want me to find the first 4 terms. So 1, 2, 3, 4. So given the first term and the common ratio, find the first 4 terms. Now, my first term that they...
Sorry for the interruption.
Hold on a second.
Students, if you are scheduled to take the LPAC testing, please head over to the library right now. Once again, if you're scheduled to take LPAC testing, head over to the library. Thank you.
Anybody here supposed to take the LPAC? No? All right. So anyway, we're moving on here. So A sub 1 is 3, R is 2, they tell us, right? So first term is 3. To get to the next term, I have to multiply by my common ratio. Notice I got to multiply by 2 over and over and over again. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And I'm done. Just multiply by your common ratio. Okay? So my common ratio, R, was 2. So just multiply everything by 2. And that's going to give me my set of terms. So here we go. Those are my 4 terms. And I'll do the same thing with part B. I need the first 4 terms. So 1, 2, 3, 4. A sub 1 is 2. And they want me to multiply every single term by -4. So I'm going to put times -4 down here just to kind of remind me what I'm doing. So 2 times -4, that's -8. -8 times -4 is 32. 32 times -4 is -128. And that's my set of 4 digits. So that's pretty easy too, right? Just multiplication. That's all we're doing. Okay? All we're doing is multiplication. Any questions on that one? So hopefully so far this has been easy, right? Division to find your common ratio. That was example 1. And then example 2 is if I give you the first term and I tell you what you're multiplying by, can you list a couple more terms? So also pretty simple. Not too bad. All right, example 3. So little by little, we're kind of making you do a little bit more. Okay? So example 3 says find the common ratio. So find R and the explicit formula. Okay, so find R and then find the explicit formula. Remember the explicit formula, let me write it down for us. It's A sub n equal to A sub 1 times R to the n minus 1. All we got to do is figure out A sub 1 and R. That's it. Okay, and that's exactly what they're asking us to do, is to find the common ratio R and then find the explicit formula. So to find the common ratio, I'm going to have to divide. So I'm going to divide like this. Okay, so let's see. Negative 12 divided by negative 4 is 3. Now remember, you have to divide all the terms. Don't just do like 1 and say like, okay, that's R. Because sometimes the last term doesn't divide to the same number. So you got to check them all. Negative 36 divided by negative 12, well, that's 3. And negative 108 divided by negative 36 is also 3. So that means that my common ratio is 3. Okay, so now I can write my formula. So here's the, let me put a box around this because this is one of the answers they wanted. So my formula is A sub n equal to, what's A sub 1? Negative 4. It's the first term, right? First term. So negative 4 times, and then R, which is 3, to the n minus 1. And there you go, you're done. I'm going to put an or right here, just in case you want to write it the other way. You could put negative 4 times 3 to the n minus 1. I like writing it the second way because when I start to teach upper division math, I know, fix that. When I start to teach like upper division math, like calculus and stuff like that, any little dot or extra marking can sometimes be confusing. So for us, putting a multiplication dot is kind of weird. So we'd rather use the parentheses. So I prefer the bottom one, but it doesn't matter. Either one is the same. Okay. Don't choose the bottom one just because I do it. Just choose whatever you're more comfortable with. Okay. Just know it can be written 2 different ways. Okay. Know that it can be written 2 different ways. Any questions on this one? Pretty easy, right? Divide, and then once you know that common ratio, if it exists, then make it fit into a formula. So let's do this next one really quick. Again, calculators might be helpful in some of these cases. So I got 10, 50, 25, and 25 over 2. Those are my terms. Okay, so I'm going to get these numbers and divide them. So 50 over 100. Well, that reduces to half. 50 over 20, I'm sorry, not 50 over 25, 25 over 50, that reduces to half. And then 25 over 2 divided by 25. Well, remember, we can't divide fractions. We have to multiply by the reciprocal. So this is basically 25 over 2 divided by 25, which is 25 over 2, times 1 over 25. So these will cancel. So my answer is half. So notice all of my division ended up in half, half, and eventually half. So I have a common ratio. If you had a calculator, you could just type in 25 halves divided by 25. It should give you a half. But all of this basically told me that R is half. Okay? So now let me write the equation. So equation is A sub n equal to A sub 1, which A sub 1 is 100, times R, which is half, to the n minus 1. Either that or you can do A sub n equal to 100 times half to the n minus 1. Again, I prefer the bottom one just because it's more useful for me, but you choose whatever you like. So we got one more example, one other way to approach this, and then I'm going to give you guys your homework. Are we okay so far? R values, again, very important. We find our R value and then just write out an equation for this. So here's the last one. So example 4 says if I give you the formula, so here it is, a sub n equals to -4 times 3 to the n minus 1. Can you find the common ratio and then find the term named? Find a sub 10. Okay, so if I give you the formula, can you find the common ratio, the R value, and the term named? So what's the R value in part A? Look at the equation. What's supposed to be R? Let me show you the original equation. So right here, look at this stuff right here. Okay, so it's a sub 1 times R to the n minus 1. Okay, so what's my R value for this one? 3. Okay, it's already given to you. We don't have to solve it. It's right here. Okay, so that's the first part. And then they say find a sub 10. That means plug in a 10 for n. So a sub 10 is equal to -4 times 3 to the 10 minus 1, which is -4 times 3 to the 9th. Now I don't know what that is in my head, so let me do this on a calculator if you guys don't mind waiting. So give me a second. Here we go. So -4 times 3 to the 9th. That's negative 78,732. Okay, so there's your answer. So this isn't that hard. It's actually, I think, a little easier than the arithmetic sequence stuff. Okay, so let me give you one more and then we're done. Now, just out of curiosity, for this next one, we have a sub n equals to -2 to the n minus 1. Find a sub 15. What's my R value for this one? -2. What's my a sub 1? 1, okay? I just want to put this right here. So I'm just going to put FYI. Okay? A sub 1 is 1. You don't have to identify that. I didn't ask you to do that. Okay? But it's just one of those problems that sometimes are a little tricky because you don't see the numbers, so people don't know what to do sometimes. But a sub 1 is 1. It's right here. Okay? We just don't see it. Okay? So again, R value is either going to be inside of the parenthesis or after the time symbol. All right, now let's go ahead and find a sub 15. So a sub 15 is equal to -2, 15 minus 1. Well, that's -2 to the 14th. Now, guys, notice there's a parenthesis around it. When you guys do this on a calculator, please put the parenthesis around it. Anytime you take a negative number to a power, put it with parentheses, or else the power may not apply properly. So -2 to the 14th comes out to 16,384. So that's a sub 15. If you don't put the parenthesis around it, your answer will come out negative, and that's incorrect. Okay? Because whenever you punch into a calculator, when you type this into a calculator, -2, so you put the negative, and then you put 2 to the power of, and you put 14. This is what it thinks you want. Okay, let me show you. It thinks that you're doing this, which you might say, well, yeah, that's what I'm doing. But your calculator, when you write it out like this, your calculator says, okay, you want me to do this first and then apply the negative. So it's going to do 16,384 and then put the negative in the front. That's what it thinks you want it to do. So what you need to do is put a parenthesis between here and there, because that's what you actually want it to do. You want it to take -2 to the 14th, not just 2 to the 14th. So calculators can be a little tricky. Anytime you guys use powers, make sure that you guys use parentheses according to what you want it to square or cube or whatever. Okay. So that's it. Let me go ahead and pause this and I'll give you guys your homework.